So for Quideo number 4, it starts with a basic question, which is telling us about the Census Bureau reporting that households spend on average 31% of their total spending on housing. And a homeowners or home builders association in Cleveland believes that the average is lower than that. So they sampled 40 households in Cleveland. And so the HO for this problem is mean equals 31%, and the HA is mean is less than 31%, and the population standard deviation they give us is 9.6%. So A is asking what is the sampling distribution of the mean percent x bar that the sample spends on housing of the null hypothesis is true, and then it asks us to sketch the density curve. So we would just find the standard deviation by plugging in that 9.6 and dividing it by the square root of the total number of samples, which was 40 households, and you get 1.5179. And so on this density curve, the mean is the 31%, and I did the 3 standard deviations, so you would just add that number 3 times on this side and then subtract it 3 times on this side. And so that's what that density curve would look like. And then for B, it's saying suppose that the study finds x bar equals 30.2%, and then I marked that here. And then it asks, suppose that the study results in 27.6%, and it's asking us to mark that. So I did that here. And it's asking to explain why one result is better evidence that Cleveland spends less than 31% on housing, whereas the other one is not. So I just said if the sample were to find that 30.2% of the spending goes to housing, it is not enough of a deviation from the HO, which is the mean equals 31%, for it to be good evidence for the argument the HA, which is the mean is less than 31%. However, if the sample mean was 27.6%, it is good evidence because it's 2 standard deviations below the mean. So I'm just saying that the 30.2 just isn't far away enough from the mean for it to be significant enough to support our argument that the mean is less than 31%. And then C is just asking us to shade the area under the curve that gives the p-value for the result of x bar equals 30.2. And so I just did that right there. And then moving on to the advanced question. It's saying that this research company polled a random sample of 799 US teens about the internet or their internet usage, and 49% of them reported that they had misrepresented their age online to get on certain websites and online services. And A is just asking us to find the margin of error for this poll if we want 95% confidence interval. So the margin of error equation or problem, I guess, is just plus or minus z star times the square root of PQ over N. And so plugging that in is plus or minus the z star of the 95% confidence interval, which is 1.96. And then the P they gave us was the 49%. So I just did the 0.49 and then times the Q is 0.51 and then over the 799. And I got a margin of error of plus or minus 0.0347. And then it's asking us to explain the margin of error in context. And basically, the 95% confidence interval means that we are 95% sure that the amount of teenagers that lie about their age online is 0.0347 above or below the 0.49 they reported. So it basically means that the number is between 0.4553 and 0.5247. C is just asking that if we only need to be 90% confident, would the margin of error be larger or smaller? And the margin of error would be smaller because decreasing the confidence interval to 90% would actually make the z-star smaller. So the z-star value for 90% confidence is 1.645. So when you multiply this number by 1.645, you get a smaller number.